Rationalization is a key driver in the agricultural sector, leading to an increase in the size of production buildings and an increase in the level of mechanization. In the wake of rationalization, the electric and electronic installations on a modern farm are ever more complex. It also leads to storing growing quantities of highly flammable materials, such as hay and straw, together with the animals in the same buildings. All of this increases the fire risk and fire losses. But what is a reliable fire protection scheme? To answer these questions, we must first take and answer additional questions, such as why should we safeguard animal sheds in the first place? What are the risks, causes, and damages of fires? Why is fire detection in animal sheds challenging? To answer all these questions, I will shortly touch on codes and standards before I cover the application scenarios in detail. That's where I tell you how exactly we overcome the challenges. And last but not least, a sum up of key criteria and benefits of it all. But first, a few words about the company and myself. My name is Markus Müller. I'm a director for vertical application management at Securitas. I look back on more than 30 years in various positions within the Swiss Securitas group, starting at hardware and software development, project management, up to now directing the vertical application management, where we do exactly what I tell you today, is we provide case studies and design guides. The Swiss Securitas group, to which Securitas belongs, comprises of around 25 companies, all dedicated to security and safety. The more than 16,000 employees generate a turnover of about 1.2 billion euros. Securitas itself employs around 750 people, and the group as such was founded in 1907. That means we look back on more than 100 years of experience, and we are still an independent and family-owned enterprise. So, why should we safeguard animal sheds? The growth in size of production buildings and an increase in the level of mechanization evidently leads to more animals being at risk at a single farm. Animal advocates feel strongly about the loss of thousands of animal lives in fires and other disasters. On one hand, regulation permits huge numbers of animals to be kept inside single buildings. On the other hand, smoke is the biggest cause of death for both human beings and animals. This makes the evacuation in the event of a fire a highly complex matter. Damage resulting from property loss and the loss of contracts after an uncontrolled fire incident may drive a farm out of business. It is therefore paramount to farmers to have a professionally designed fire protection scheme established, which allows to detect and react upon a fire as early as possible. What now are the risks for fires in animal sheds? What are they caused by, and what damage results from fires? Barns normally are loaded with substantial quantities of dry, flammable materials, such as bedding, hay, grain, and wood. When these materials ignite, they burn with savage intensity. Liquid fuel sources found in barns include alcohol, liniment, roof paint, and creosote, among others. The barn structure itself can be a major contributor to how quickly the barn fire spreads. Barns are often wooden structures, and they are often airy and filled with combustible materials such as wood stalls and hay. The most common cause is equipment failure, both heating and electrical. However, smoke is the major hazard in the event of a fire, causing most animal and human death. Only in case a fire is discovered in its incipient stage, there is a good chance to effectively put it out. Smoldering fires, for example from faulty electrical installations, can last hours, in some cases days, before they break out into flames. Statistics show that in 50% of the cases, the cause of the barn fire is never determined. While the NFPA states that $38 million are annually caused for property damage between 2006 and 2010, the Animal Welfare Institute focuses on the loss of animal life and highlights that from 2013 to 2017, more than 2.7 million US farm animals died in barn fires that potentially could have been prevented. Consequential loss of business contract and the economic damage resulting from it to the farmers themselves is considered substantial, although it is statistically not widely documented. Barns and animal sheds pose several changes to an effective fire protection system, such as environmental challenges. We have a high humidity and aggressive gases. We have overvoltage surges due to lightning strikes. We have loads of dirt and dust due to material handling, such as straw or hay. An animal shed, the facility itself, is a large, partly open space in which changes in the airflow are very common, as cooling may be required during the summer and heating during the winter. Airflow conditions may also change during the day. There are only few regulations in force. For Scandinavian countries, for example, there are codes and standards in force which cover the requirement for products used. Here, the FG 743. And also their application in farming facilities. Here, the NS 3960. The design of a fire detection system needs to be simple and to meet deemed to satisfy fire and building safety provisions, such as the NFPA 1, NFPA 72, or the British Standard 5839-1. However, applying a performance-based design approach addresses risk-based detection needs over and beyond prescriptive requirements to ensure business operations and asset protection as recommended, for example, in NFPA 150 or CFPA E17. What does applying a performance-based design approach to address risk-based detection needs mean? To answer that question, we need to look at it from different perspectives. The regulators, for one, their perspective is to protect lives. The regulators issue codes and standards to cover health and safety of persons and not necessarily of animals in our context. Codes and standards such as the NFPA 15, the standard for water spray fixed systems for fire protection, cover these health and safety issues. However, the regulator does not concern themselves with asset protection or property loss issues. That is the domain of the insurers. FM Global issues recommendations such as the Property Loss Prevention Data Sheet, the DS 919, which covers wildland fire, in some issues in it relevant to the farming industry. But they offer no coverage for prolonged business interruption. The operator's ultimate goal is ensuring that his business runs smoothly. Now, how do we achieve all this? Compliance-based design mainly covers the regulator's goal. To cover the other two goals, we need to apply a performance-based design approach. That is to consider fire ignition scenarios and design for these scenarios. In other words, we need to seriously ramp up from sprinklers. We need early warning coupled with a decisive response. Before I touch on the application scenarios, harsh environments in animal sheds, the range of solutions approved varies considerably. The approved solution to overcome the challenges that I mentioned before is to design a reliable early warning fire detection system with multiple alert levels that is capable of operating in harsh environments with aggressive gases, high humidity, and lightning strikes. But before we look at some key design factors in more detail, let's explore early warning fire detection a bit further. The key objective of an early warning fire detection is to gain time. Time to adequately react to the development stages of a fire. This is the typical development of a fire. In its incipient stage, for example, caused by the smoldering wire due to an overload, there is only limited smoke produced. Again, the incipient stage may develop over hours or in some cases over days. To react to the growth of, to reach the growth period of a fire, during the early stages of a fire, the smoke concentration is typically below 2% per meter obscurity. Only in later stages, the smoke concentration will rise above 2% per meter, thus reaching a level where standard point-type smoke detector could possibly trigger an alarm. However, standard type point detectors do not meet the challenges we mentioned earlier. A fire must reach a significant size to release enough heat to initiate sprinklers. Once the fire service call is called, the fire brigade will take some time to reach the location. They will then need a certain time to assess the situation and set up gear before they can start fighting the fire. From a business continuation and asset protection point of view, clearly, an early detection of a fire minimizes loss and interruption While the later a fire is detected, the greater our loss and business interruption. As I mentioned earlier, we want to ramp up from sprinklers alone to an early warning system and a decisive response. That is where the 5 levels of Securitas Smoke ASD 535 HD come into play. Detected at the first level, a fire incident can be prevented in most cases. If the smoke concentration rises to trigger the second level, local firefighting may help preventing larger damage. At a later stage, shutting down ventilation systems and starting the evacuation of the animals may be the right response to the developing situation before a fire service call is issued, notably a lot earlier than with sprinklers alone. Remember, it's all about gaining time. Even before the fire releases a thermal load to initiate the sprinklers, triggering a pre-action suppression system helps minimize losses. Now, before we dig into some key design factors, I would be happy to answer a few spontaneous questions.
Marcus, I've got a question. Is the aspiration smoke detection principle suitable for all types of animals in sheds? Or can it be used for horses, cows, and other animals?
Yes, that's it. In fact, it depends very much on the dust concentration in an animal shed. So we experience that it is very well suited for horse sheds, cow sheds, lamb sheds, pigsties. It's a bit less suited for poultry sheds. The chicken move around a lot faster. They create much more dust. And there we would recommend to use a professional industrial grade beam detector. But for the sheds mentioned before, we can ASD is very well suited as a detection method.
All right, thank you. We don't have any further questions at this stage, so you may please proceed.
Thank you. Okay, now what are the key design factors? As an animal shed, design and utilizations differ. We just found out cows, horses, pigs, and so on. The fire protection solutions differ as well. When designing an early fire detection solution based on the Securitas Smoke ASD, bear in mind the following key factors. Use the Securitas Smoke ASD 535 HD and the accessories which are hardened for the use in environments with corrosive gases and feature an enhanced overvoltage protection. Airflow changes and changes in the airflow within the protected area due to ventilation systems installed and/or natural ventilation. Bear in mind the general characteristics of the building or the protected area. For example, is it a flat roof, a pitched roof with or without ventilation through openings in the pediment, considering possible smoke stratification effects, and so on. Consider the general partitioning of the protected area. For example, are there milking stalls, individual stalls for calves and foals, and so on. Employ or apply localized protection of electrical equipment, such as robotic mixers or feeders, grooming brushes, milking stalls, and so on. And last but not least, ensure that alarm and fault notifications mentioned before, the 5 levels, can be heard and are also reacted upon, in particular in cases where the shed is at a remote location or is operated completely unattended. Now, some key design factors in more detail. The Securitas Smoke ASD 535 HD or heavy duty is the recommended choice for harsh environments found in animal sheds. It can operate in temperatures ranging from -30 to +60 degrees centigrade with a relative humidity of up to 95%. The fan's suction pressure of more than 400 Pascal ensures reliable detection of smoke when there is a high airflow and a high degree of change in the airflow. In addition, the ASD itself offers a protection class of IP66 according to EN 6259. In addition, all printed circuit boards within the ASD 535 HD are coated, and an optional overvoltage protection board is available. This allows for the ASD to be installed without the need of costly additional protective housing. Another key design factor is to consider airflow and changes in the airflow, as I have mentioned before. For a large open space, such as an animal shed, a Securitas Smoke ASD early warning fire detection system is used for ceiling detection to meet the prescriptive code requirements, but it is also used in enhanced detection performance designs to meet risk-based fire safety objectives to avoid losses due to fire damage and to ensure business continuity. The recommendations from NFPA 72 regarding the monitored area in function of the air exchange rate ranges from 6 exchanges per hour to 60 exchanges per hour. In case the ventilation of the shed has a significant impact on the dispersion of smoke, it is strongly recommended to analyze the air currents in the protected area and to subsequently incorporate the results of these analyses into the design of the early warning fire detection system. An animal shed is largely an open space, often with a roof construction with joints or beams. In such constructions, the sampling pipes are generally installed under the beef or under the roof if there is a smooth ceiling. The ratio between room height and beam depth is defining the placement of the sampling holes. When the beam depth is less than 10% of the ceiling height, smooth ceiling spacing is applied and the sampling points are placed on the bottom of the beams. See the green sampling holes on the slide. If the beam depth is greater than 10% of the ceiling height, 2 cases must be distinguished. The beam spacing is less than 40% of the ceiling height, meaning the beams are closer together. Use smooth ceiling spacing again and place the sampling holes at the bottom of the beams. Again, sampling holes in green. beam spacing is greater than 40% of the ceiling height, meaning the beams are spaced wider apart, a sampling hole shall be placed on the ceiling level within each beam pocket. That would be the sampling holes shown in blue in this slide. The orientation of the holes is perpendicular downwards. The spacing, in case the monitored area, in case the area monitored by one sampling hole, is defined by the monitored area in relation to the air exchange rate defined in the NFPA 72, as mentioned before.